So the last class what we were doing now, so equilibrium. In the equilibrium, in the starting day we discussed types of equilibrium, right? Chemical equilibrium, ionic equilibrium. Once again, physical equilibrium, chemical equilibrium, homogeneous, heterogeneous. So like that we discussed a number of types, right? Then afterwards we discussed Kc and Kp. What is the relationship between Kp is equals to Kc into RT power delta N. Delta N G means what? Number of moles of stoichiometric coefficients of gaseous products minus number of stoichiometric coefficients of gaseous reactants. Yes, R means universal gas constant. We have to take 0.08, temperature 293 Kelvin. So Kc and Kp. How we need to write the Kc? Kc is equals to concentration power C power D by A power A and B power B. B power B. So how can we write the Kp? Kp is equals to P C power C into P D power D by P A power A into P B power B, like that. So if any in the reactants and products any one gas molecule is there, that cases Kp is defined. The square brackets nothing but I told you active mass, nothing but concentration N by V. This is P is nothing but partial pressure. What is the partial pressure? Partial pressure is equals to what? Mole fraction into total pressure. Total pressure. I told how to calculate. So at equilibrium, right? And so equilibrium, to attain the after attaining the equilibrium, there is no change in the measurable properties like concentration, density, temperature, and all the things. For example, A plus B gives rise to C plus D. So is K is equals to, imagine K1. If I am reversing this, what exactly happens? C plus D gives rise to A plus B. K is equals to 1 by K dash. K is equals to 1 by. So when the equation is reversed, the equilibrium will be reversed, right? So and whenever we are multiplying with any number, right, 2 or any of, for example, of A plus of B gives rise to of C plus of D. So K is equals to, how can we write? K power 1 by 2. So if we are multiplying with 2, this equation with multiplying with 2, 2A plus 2B gives rise to 2C plus 2D. Now K is equals to K dash power 2 square. So when we are adding the two equations, for example, equation 1, A plus B gives rise to C, C gives rise to D. This is K1, this is K2. So when we are adding these two, what exactly happens now? C get cancelled, the A plus B gives rise to D, K dash is equals to K1 into K2. So when we are adding the two equations, we need to multiply with K1 into K2. Okay? Hello? So these things we discussed in the last classes, and QC, AA plus BB gives rise to PC plus DD. How can we write the Q? Reaction coefficient. Same like C power C, D power D by A power A and B power B. Kc is equals to what? Kc is equals to T power C T power D by A power A and B power B, right? So but Qc is nothing but what? At any particular concentration, this is equilibrium at when is attaining the equilibrium. After attaining the equilibrium, we will write Kc. If Qc is equals to Kc, right? So reaction at equilibrium. At equilibrium. For example, if Qc is greater than Kc, right? Backward reaction takes place. Which reaction? Backward reaction. For example, Qc is less than Kc. So forward reaction takes place. Forward reaction takes place. Okay? No. So then I told you how to do, for example, A plus 2B gives rise to 3C. Imagine. So how to calculate the Kc? For example, initially if we are taking A, B, 0 moles. So at equilibrium A minus X, B minus 2X, in this case 3X at equilibrium number of moles. Concentration if you are taking A minus X by B, B minus 2X by V, 3X by V. This is the concentration, number of moles at equilibrium, concentration. Concentration means what? Number of moles by volume. So based on that, we will write the Kc value. How can we write the Kc? Directly I am writing 3x by V whole cube by A minus X by V, V minus 2X by V square, right? So like this, so we can simplify, this is the case. So in case of Kp, how we will do? In case of Kp, for this same, A plus 2B gives rise to 3C, A, B dash, at equilibrium, nana, A minus X, B minus 2X, 3X. These are number of moles. The total number of moles, A minus X by A plus B, B minus 2X by A plus B, 3X by A plus B. How we will get the A plus B? This is A minus X plus B minus 2X plus 3X. So X will be cancelled. A plus B. So this is what, nana? Mole fraction. Total pressure into P. Partial pressure is equals to A minus X by A plus B into P, B minus 2X by A plus B into P, 3X by A plus B into P. What is, how can we calculate this total pressure? Total pressure will calculate from PV is equals to nRT. P is equals to, yes, ideal gas equation, N by V RT. So like this we will calculate the total pressure, number of moles and all we calculated. So then Kp, how we will write? Kp is equals to, same row, 3x by A plus B into P total by A minus X by A plus B to P total, P minus 2X by A plus B into P total square. So you can solve it, you will get the answer. And degree of dissociation also I already discussed yesterday. What is the degree of dissociation? Alpha is equals to what? Number of moles dissociated by initial moles are taken. So number of moles are dissociated by initial moles of taken. For example, 2HI gives rise to H2 plus I2. H2 plus I2. Normal cases A dash dash A minus 2x x x. Normally number of moles in terms of degree of dissociation, how we will do? 2HI gives rise to H2 plus I2 A dash dash. It is alpha is equals to what? Number of moles are dissociated, 2x A, right? Alpha is equals to 2x is equals to A alpha, x is equals to A alpha by 2. So this we have to sub A minus alpha, right? 2x nothing but A alpha. No. It is xx means what? A alpha by 2, A alpha by 2. So this is the way which we need to do for degree of dissociation. Degree of dissociation, Kc, Kp, degree of dissociation, equilibrium constant, characteristics of equilibrium. So those things I gave you different each and every point, right? Next, today we will discuss Gibbs free energy as well as equilibrium constant. Gibbs free energy, so write it down here. Thermodynamics of equilibrium. Delta G is equals, write it down, delta G naught plus RT ln Q. Delta G is equals to delta G naught plus 2.303 RT log Q. For this particular reversible equation, at equilibrium, what exactly happens now? Delta G is equals to 0 and Q is equals to K, right? K equilibrium. So if you are applying this, delta G naught is equals to minus RT ln Q, delta G naught is equals to minus 2.303 RT log EQ. Write it down. Always at equilibrium, delta G is equals to 0, Nana. And QC, I already told you, QC is equals to KC. So we know delta G naught is equals to delta H minus T delta S naught. So delta D naught place, if you are applying this one, minus 2.303, right? The same value if you are applying here. So delta H naught T delta S. So log EQ, so minus 2.303 RT, so just we are come, right? Putting down, TT get cancelled, so it is T only. So just write it down this. If delta G is negative, reactions are spontaneous. Delta G is negative, reactions are spontaneous. If delta G is positive, reactions are non-spontaneous. Change in enthalpy, delta S means entropy change. For a reaction, always it should be spontaneous, means delta H should be negative and delta S should be also positive. That case is reaction always spontaneous, nothing but delta G is negative. So nothing is there, so previous case whatever delta G value is there, so that value just we are keeping on this case. Yes, so if you are writing the log EQ by 1 by T, right? Endothermic reactions, no? We'll get this type of graph. Slope is equals to delta H, Y is equals to mx plus C. So this one, Y is equals to mx 1 by T mx plus C. C means this is the interceptor, delta S naught by R. Slope is delta H by 2.303 R. Okay, write it down. If delta H is positive, that is endothermic reaction. So always remember that Y is equals to mx plus C, will get this negative slope like this. Y axis, case will get the slope is intercept. Y is equals to, for exothermic reactions, if temperature increases, so here is K equilibrium is decreases. Delta H naught by 2.3. Even in chemical kinetics, also Arrhenius equation also will get this equation. Arrhenius equation in chemical kinetics, the second year term. Write the formula. Write it down. So we know delta G is less than 0. Nothing but delta G is negative, reactions are spontaneous. If delta G is equals 0, reaction at equilibrium. The delta G is greater than 0, nothing but positive, reactions are non-spontaneous. Reactions at constant temperature, right? Temperature and pressure, the reactions are feasible now. Lowering its Gibbs free energy. So write it here. Delta G is negative. Negative, reactions are spontaneous, 0, equilibrium. If both positive, delta G is positive, reactions are non-spontaneous. Okay, write it down. Important point, equilibrium occurs at a minimum value of Gibbs energy. So in this case, minimum point. Gibbs energy, extent of reaction. Next, no. So the last topic in this chemical equilibrium, the Chatelier principle. So first, I'll take one example. N2 plus 3H2 gives rise to 2NH3, and delta H is, I'm giving you negative. Negative means what? Delta H is negative means what? Reactions are spontaneous, right? So the forward reaction is exothermic, backward reaction is endothermic. Okay, forward reaction is exothermic, backward reaction is endothermic. Equilibrium, right? Equilibrium, for example, here is, we'll speak in terms of concentration, pressure, temperature, and addition of inert gas. Addition of inert gas. So these are the important steps which we need to understand. So I'll tell you in a shortcut mode and easy mode. First, concentration. For example, in the preparation of ammonia, Haber's process. For example, if we want to prepare ammonia, means if we want to prepare ammonia means reaction should move forward direction. Yes or no? For that particular case, concentration, what is the role of concentration? Right? If we are increasing the concentration of reactants, so then reaction moves to the forward direction. Right? If you are increasing the concentration of reactants, then reaction moves to the forward direction. This is a case 1. Case 2. What is a case 2? So no need to increase the reactants concentration. We need to decrease the product concentration. This is about the concentration. If you are increasing the reactants concentration, for example, products concentration increase చేసాం అనుకోండి, backward reaction వస్తుంది. అప్పుడు backward reaction కావాలంటే ఇంకోటి, we need to decrease the reactants concentration. First point. Got it? For forward reaction, reactants concentration we need to increase, otherwise product concentration is decrease here. For example, backward reaction avalante, we need to increase the product concentration, reactants concentration and decrease here. So this concentration one we will use in applications of common ion effect. What is common ion effect? In buffer solutions, for that cases we will use common ion effect. For example, try to understand CH3 COOH, weak acid, CH3 COO minus H plus. So this is the equilibrium. This in the equilibrium case, if you are adding some small amounts of acid, CH3COO minus Na plus. If you are adding some small amounts of acid here, acid means H plus ion concentration. H plus ion concentration, if you are adding the H plus, which concentration is increasing? H plus ion means product concentration is increasing, reaction moves to the backward direction. This is nothing but common ion effect. Common ion effect. This is called common ion effect. The same thing we will discussing in the Chatelier principle. Next, Nana, I'm just speaking about pressure. Next, if you are increasing the pressure, simply write it down. So reaction moves, always reaction moves. Reaction moves more number of moles to less number of moles. So simple one statement is more than enough. When we are increasing the pressure, it is 1 plus 2, total 3. 1 plus 3, total 4 moles are left side, 2 moles are right side. If you are increasing the pressure, forward reaction is takes place or backward? For more number of moles to less number of moles, means forward reaction is. If you are increasing the pressure, write it down. If you are increasing the pressure, reaction moves more number of moles to less number of moles. Next, Nana. Temperature. Delta H is negative, right? So means what? It is forward reaction is which, Nana? Forward reaction. Forward reaction is what? Exothermic. Backward reaction? Endothermic. Backward reaction is endothermic. Exothermic, endothermic. Exothermic means what? It is liberating. Endothermic means what? It is taking or absorbing. Right. Always remember, right, if I am increasing the temperature, which reactions are takes place? Forward or backward? No. If I am increasing the temperature, backward reaction is takes place. If I am decreasing the temperature, forward reaction is takes place. Forward reaction is. Okay, write one point, right? Always exothermic reaction means already temperature is given, right? So exothermic reactions are favorable, low temperatures. Endothermic reactions are favorable in high temperatures. It is low temperatures are favorable. In this case, high temperatures are favorable. Write one statement, always exothermic reactions are favorable. Write it down. Always exothermic reactions are favorable, low temperatures. మనకి ఇక్కడ ఏంటి అమ్మోనియా ఫామ్ అవ్వాలా. అమ్మోనియా ఫామ్ అవ్వాలంటే ఏంటి కావాలి? ఫార్వర్డ్ రియాక్షన్. ఫార్వర్డ్ రియాక్షన్ అవ్వాలంటే ఏంటి? ఎగ్జోథర్మిక్ మీన్స్ లో టెంపరేచర్స్ ఆర్ ఫేవరబుల్. లో టెంపరేచర్స్ ఆర్ ఫేవరబుల్. లో టెంపరేచర్ ఈజ్ ఫేవరబుల్. Favorable for the formation of ammonia. Low temperatures are favorable for the formation of ammonia. They are asking one examiner's favorite question here. In the Haber's process preparation of ammonia, which of the following conditions are more? Option A, high pressure and high temperature. Okay, high pressure, high temperature. Option B, low pressure, low temperature. Option C, high pressure, low temperature. Option D, low pressure, high temperature. Like this, examiner's favorite question. What is the answer? Right? High pressure, more number of moles to high pressure and low temperature. High pressure and low temperature. Very, very, very important. For example, I'll give you one more. A plus 2b gives rise to 4c, whatever the equation. Okay? If I'm increasing the pressure, in this case, forward reaction takes place or backward reaction? Forward reaction takes place or backward? Backward. More number of moles to less number of moles. 4 moles in this case, 3 moles. More number of moles to less number of moles. Backward reaction takes place. Imagine, right, this delta H is equals to positive at high temperatures. If temperature increases, forward reaction or backward reaction? If temperature increases, forward reaction or backward reaction? Forward reaction endothermic. Backward reaction exothermic. So ఇక్కడ temperature increase చేసిన, temperature increase చేస్తే ఏం రియాక్షన్ అవుతుంది? Forward. Temperature increase చేస్తే forward reaction is favorable. Delta H is negative. First we need to cross check this. Delta H is negative means what? Forward reaction is exothermic. Backward reaction endothermic. Right? Temperature decrease means what? Bit low temperatures. Favorable exothermic. Exothermic means forward reaction. In this case, if I am increasing the pressure, what happens? Forward or backward? No change, because number of moles 3 and 3. No change. Next one, addition of inert gas. Last point. Addition of inert gas. (2NH3). Addition of inert gas at constant volume. At constant volume there is no change. Write it down. Addition of inert gas. Addition of inert gas. In this case, addition of inert gas, two conditions we'll see: at constant volume, at constant pressure. At constant volume, addition of inert gas at constant volume. What, Nana? No change. No change. At constant pressure, addition of inert gas at constant pressure. Right? At addition of inert gas at constant pressure, what happens? Reactions are moving from reaction moves from less number of moles to more number of moles. More number of moles. Write it down. At constant volume, no change. At constant pressure, reactions from moving from less number of moles to more number of opposite pressure. So in this case, if you are adding the inert gas at constant volume, no change. If you are adding the at constant pressure, what exactly happens? Forward reaction or backward reaction? Less number of moles to more number of moles. Backward reaction takes place. సింపుల్ గుర్తుపెట్టుకోండి, ఆ ప్రెషర్కి అయితే ప్రెషర్కి ఆపోజిట్. క్లియర్ ఎవ్రీవన్? హలో, నేను 4 పాయింట్స్ చెప్పాను. ఒకటి కాన్సన్ట్రేషన్, ప్రెషర్, టెంపరేచర్, ఎడిషన్ ఆఫ్ ఇనర్ట్ గ్యాస్. కాన్సన్ట్రేషన్ ఇంక్రీజ్ చేస్తే రియాక్టెంట్స్ ఇంక్రీజ్ చేస్తే ప్రొడక్ట్ సైడ్ వెళ్తుంది, ప్రొడక్ట్స్ ఇంక్రీజ్ చేస్తే రియాక్టెంట్ సైడ్ వస్తుంది. ప్రెషర్ ఇంక్రీజ్ చేస్తే ఏంది? మోర్ నెంబర్ ఆఫ్ మోల్స్ టు less number of moles. Temperature based on exothermic and endothermic. Endothermic reactions are favorable at high temperatures. Exothermic reactions are favorable low temperatures. Based on that, we need to cross check. Delta H is negative means based on that I already explained. Addition of inert gas at constant volume, no change. addition of inert gas at constant pressure, reactions are moving from less number of moles to more number of moles. Okay, got it? 4 points. So now we'll discuss once again in a PPT. Industry, the aim is how to maximum product yield, minimum energy expenditure. అంతే కదా, ఎక్కడైనా కానీ మనకి ఎక్కువ ప్రోడక్ట్ రావాలి, తక్కువ ఖర్చు పెట్టాలి. After equilibrium established, more products formation stops. Equilibrium can be disturbed, right? So for example, imagine in this case N2 plus 3H2 gives rise to 2NH3. So ఇక్కడ in this process ammonia ఏం చేయాలి మనకి? సో అమ్మోనియా షుడ్ బి మోర్ ప్రొడక్ట్ ఫామ్ అవ్వాలి. దానికోసం ఏంటి, మొత్తం ఫార్వర్డ్ రియాక్షన్ జరగాలంటే ఐ టోల్డ్ యూ, రైట్? ఒకవేళ ఇక్కడ అమ్మోనియా ఫామ్ అయిన తర్వాత మనం రియాక్షన్స్ స్టార్ట్ చేసాము, అమ్మోనియా ఫామ్ అయింది, రైట్? సో మనం పోయి నిద్రపోయినాం, ఏమవుతుంది? అమ్మోనియా కాన్సన్ట్రేషన్ ఇంక్రీజ్ అవుతుంది. అయిన తర్వాత ఏమవుతుందిరా, మళ్ళీ బ్యాక్వర్డ్ రియాక్షన్ అవుతుంది. అమ్మోనియా ఫామ్ అవ్వగానే ఏం చేయాలి, మనం తీసేయాలి, right? So Chatellier's principle, if a change is applied, right, to the system at equilibrium, then the equilibrium will be shifted the direction in which minimize the effect of change applied, right? The equilibrium established again under the new conditions, right? So I already told you this same example I am taking once again. Right, already it is imagined it is in the equilibrium, right? So if a change is applied to the system, ante enti, we are increasing the concentration of reactants concentration. అప్పుడు ఏం చేయాలి మరి, ఈక్విలిబ్రియం అవ్వాలి కదా. ఈక్విలిబ్రియం అవ్వాలంటే ఏంటి, ఇన్ విచ్ ద మినిమైజ్ ద ఎఫెక్ట్, ఏదైతే మనం ఇంక్రీజ్ చేసిన కాన్సన్ట్రేషన్ ఉందో అది తక్కువ అవ్వాలంటే ఏంటి, సో అవి మళ్ళీ ఫార్వర్డ్ డైరెక్షన్కి వెళ్ళిపోయి సో రెండు ఈక్విలిబ్రియం అనేది ఎస్టాబ్లిష్ అవుతుంది, రైట్? రైట్ దట్ పాయింట్ ఇఫ్ యూ వాంట్. ఏ చేంజ్ ఈజ్ అప్లైడ్ టు ద సిస్టమ్ ఎట్ ఈక్విలిబ్రియం, రైట్ ఇట్ డౌన్, రైట్ ద స్టేట్మెంట్. నెక్స్ట్ ఫ్యాక్టర్స్ ఎఫెక్టింగ్ ద ఈక్విలిబ్రియం, రైట్? చేంజ్ ఇన్ ద కాన్సన్ట్రేషన్ ఆఫ్ ద reactant or product. I already told you the reactant concentration increases, product, right? Reaction moves to the forward direction. Change in temperature, change in pressure, change in volume, effect of catalyst and effect of, I told you effect of catalyst. So when we are adding the catalyst, what exactly happens? The equilibrium will attains, right, faster mode. Change in the concentration, I told you, right? मैंने बताया था, right? मैंने क्या बताया? N2 plus 3H2 gives rise to 2NH3, right? If we are increasing, right, नाइट्रोजन का और हाइड्रोजन का concentration बढ़ते तो reaction forward, right, forward जाएगा. If the concentration of components increases, reaction shifts in the direction. For example, if you are increasing the concentration of products, reaction moves to the backward direction. If you are increasing the concentration of reactants, reaction moves to the backward direction. Right? If the concentration of the component is increased, reaction shifts in the direction which tends to decrease the concentration. In this case, A plus B gives rise to C plus D. Right? Addition of A and B. If addition of A, B, what exactly happens? Equilibrium shift to the forward direction. Because we are increasing the concentration of reactants, automatically forward reaction takes place. जब भी A का B का concentration बढ़ते तो, right? So reaction moves to the forward direction. मतलब ये भी C का D का भी increase करते तो forward backward reaction हो जाएगा. Based on this, for example, based on this also, right? I am increasing the A and B increasing the concentration. A B increasing concentration means automatically QC will be decreases because the denominator, right, decreases. If the right QC is decreases, KC will be high. KC will be high means what? Forward reaction. Nothing but directly we can say. Based on this expression also we can say, otherwise by seeing the equation also we can tell. right? If the A concentration, B concentration is decreases, automatically C concentration, D concentration is increases. So concentration of the added species A and B will be more at new equilibrium, right, than the equilibrium under the similar set of conditions. I already told you. So same example. Same Nana. If I am increasing the C and D, automatically what exactly happen? KC QC backward reaction is takes place. So take the screenshot if you want. So based on this relationship also we can explain. Change in the concentration same as it is Nana. So conclusion, addition of any solid component does not affect the equilibrium. Right? Equilibrium reactants increases, equilibrium towards the forward direction. Right? Equilibrium shifts backward direction if the product concentration is increases. Write this one point. Addition of any solid component does not affect the equilibrium. This is important point, Nana. Just note it down this. The above point, just note it. Addition of any solid component does not affect the equilibrium. If the temperature increases, reaction shifts in the direction of temperature is decreases. If the temperature decreases, reaction towards right temperature increases. In this case, delta H is negative. Means what? Exothermic. If temperature increases, what happens, Sarah? Reaction shift in the direction of where the temperature is decreases. Simple. If it is exothermic reaction, the forward reaction is exothermic, then backward reaction is endothermic. Right? If the temperature increases, reaction shifts to backward direction. Yes or no? In this case, if it is forward reaction is endothermic, temperature increases. Right? What exactly happens? Forward reaction is takes place. Simple. Forward reaction endothermic, backward reaction endothermic. Reaction shifts to the forward direction. If the forward direction is endothermic, right? If temperature increases, forward reaction is takes place. Simple. So this is already we discussed when two conditions log K2 by K1 delta H by 2.303 R 1 by T1 by T2. Change of pressure I told you. So more number of moles to less number of moles. Simple one statement which I gave you. This is explanation. On the increasing of the pressure, the equilibrium shift direction, right? Which pressure is decreasing. Number of moles of reactant decreases, vice versa. So means pressure increases what? Large number of moles of gas. Nothing but what? No? Simply try to understand delta Ng is equal to 0. There is no shift because number of moles both the cases same. Okay. Next. In this case, more number of moles to less number of moles. Means backward direction is takes place. Okay. Simply reaction goes to the backward direction. So from if you are increasing the pressure, QP, PB square P, QP is directly proportional to P total pressure. No. If pressure increases, QP increases. QP increases means, right? KP is less than KP. So backward reaction is takes place. In terms of like that also we can say, otherwise directly I told you what? If you are increasing the pressure, more number of moles to less number of moles. By seeing the equation we can say simply. In this case, forward reaction is takes place. More number of moles, less number of moles, simple. In this case, no shift because number of moles both are equal. Effect of pressure, solids and liquids cases, incompressible, right? Negligible, obviously. Change in pressure has no effect equilibrium involving in case of solids and liquids. Change in volume, effect of change in volume. Volume increases, pressure is decreases, right? Vice versa. If volume increases, reaction moves to the forward direction. Goes forward direction means less number of moles to more number of moles. In this case, no change volume. The volume is, I already told you, no need actually. Effect of catalyst. This is important. I told you. Effect of catalyst means catalyst lower the activation energy, both forward and as well as backward reactions. It alters the forward and reverse the rate of equally same. Equilibrium will be attained faster. So whenever the catalyst we are using, equilibrium will be attained faster mode. So what is the catalyst? When we are adding the catalyst, there is no change in the catalyst, but it increases the rate of reaction. So addition of inert gas at constant volume and constant pressure, I told you, right? Inert gas, the number of moles of gas in the system, right? No change in the moles, the reactants and products, Nana. But I told you at constant volume, no disturbance at the equilibrium, no change. Simply addition of inert gas, I told you, at constant volume there is no change. At constant pressure, I told you, less number of moles to more number of moles. At constant pressure, so equilibrium will shift the direction where the moles of gases are more. Means less number of moles to more number of moles. So in this case, backward reaction takes place. There is 1 mole, 2 mole. Up to here, this one just go through the NCERT and try to solve the backside questions and in-text questions equilibrium. Okay, try to solve it, and the next class I'll start ionic equilibrium. Okay, right, Nana.